It's great to be here today. A couple of personal things. I have a long history with the DOE, going back over 20 years. I think back then we did one of the largest public-private partnerships ever been done. It was a company I co-founded with my brother called Future Energy Resources Corporation, and we built a project called the Vermont Gasification Project. And I'm going to date Jim Spaeth a little bit because he was around back then, and we worked on the project together. And I remember at the first, what I guess was probably one of the first peer review, project review meetings, I fought for 15 minutes to present because I was assigned 3 hours because there was only like 10 people in the room. So it was really tough. And I also got the strangest call as project developer I think I've ever gotten. Stu Hand, a gentleman that was my own site guy, called and said, "Glenn, I've got good news and bad news." And I said, what do you want? And I said, well, give me the good news first. And he says, well, nobody was killed. And so after I picked up the phone, I said, don't want to know the bad news. So anyway, we'll go on from there. AGCO is a public company, so forward statement just saying, we hope you're all investors, but don't base any of your investments on things I will say here today, please. So who is AGCO? I would dare say most of you in the room probably don't know us by that name, but in fact, we're the third largest agriculture equipment manufacturer in the world. We have 23,000 employees and sell products in over 140 countries through approximately 3,000 dealers. But I would say most of you probably do know us by the brands that we own and represent. Massey Ferguson, GSI, Challenger, Fendt, and Vulture are our 5 main brands. And we have a history with the DOE too, and one that I want to say is a good one, and we hope it continues on in the future. And we've done some good work together. I'm going to tell you a little bit about it and get into what our history is. We started in biomass a little over 5 years ago. We were the first OEM that would have a department dedicated to biomass, and that would be as opposed to corn ethanol or storage plants. This is all about the other things, miscanthus, perennial grasses, energy cane, corn stover. And we have done a significant amount of R&D, and one thing that we made a conscious decision, which we felt like was really important, is we developed a line of equipment based on our existing lines. Now, the reason that's important is that we can teach people how to operate it. We know how to make it, we can service it, and support the units. And so that's an important fact. And that's not to say that we're not involved in things that we hope are disruptive, new technology at some point in the future, but to support this industry in its infancy, meaning the cellulosic ethanol industry, or advanced biofuels, we felt it was important that we worked with things that we understood and know how to do and didn't have to recreate new manufacturing lines. We also have started many industry and university partnerships, and as I said, participated with DOE. We're very proud of that participation and partnership, and we want to continue them in the future. On your left, the combine baler is a direct result of that initial partnership with DOE. So when we started addressing the potential barriers in the industry, we ended up developing a philosophy. Now, on the one hand, you have the Department of Energy that are supporting innovative new projects, and there's always a great race to be innovative. And on the other hand, you have farmers in the farming community, which I don't want to say won't embrace change, they certainly will, but they're much slower to. And so there's a unique thing that we're asking farmers to do many things we haven't asked them to do before. In fact, one of the projects that you heard about yesterday, the DuPont project in Nevada, as well as Poet DSM's project and the Hugoton project of Abingdon, these are areas where there has not been a lot of baling of these materials like corn stover. Don't want to say it didn't exist. It just wasn't a really prevalent practice. So we brought something new. A lot of times they're going to be asked to grow new crops. I mean, my cohort, Ken Wagenbach, and I, when we go to some conferences, we take a display of miscanthus, and you won't believe some of the interest that it creates in the farming community because people have never really seen it. They've heard about it. And so it creates an interesting concept for farmers when they say, you know, how do you grow it? What are you going to do? And you know, last but not least, we felt like it was really important to develop a total solutions approach because each one of the steps in the supply chain is dependent upon the other. So if your windrower quits, well, you're not going to make bales. If your tractor's not running, you're not going to make bales, so on and so forth down the line. So everything's very dependent, and then what we seek to do in that instance then is bridge the gap. So we have custom harvesters. That's what the CH up there stands for. Some the projects use custom harvesters. Some the farmers are doing it. We have our dealers, which right now is a barrier because we're not sure exactly how they fit into the network because of the intense activity that's going on. That's all new activity. I'll address more about that in a minute. And then, of course, it all centers around that project. So 3 of the challenges. So this is what I just mentioned about, you know, what do we do about dealer networks and service and everything else, because just one of these projects is collecting roughly, you know, 700,000 bales of material in a 60-day period of time, which you probably can't work more than maybe 30 days because of weather or other factors. And so this very intense activity, to achieve that goal, you're going to bring maybe 80 balers to town. You're going to bring probably 3 tractors for every baler. You're going to bring windrowers, bale wagons, trucks. So you're going to have 400 to 500 pieces of big, expensive equipment show up that wasn't there, you know, just a couple of years before. And so that represents a real challenge in the service area, you know, because the dealerships are not set up to service that wealth of equipment. So we've had to develop new methods to work with our dealers and help support that activity. It's very unique in that respect at this time. It's going to be really interesting, especially when you get to the second point, because now there are 3 different models. All are thought to be the best. I couldn't tell you which one will or won't, or maybe all 3 continue to develop. And they're all slightly different. So there again, you have another set of issues because you have to be able to adapt yourself to each one of those situations. And then you get down to research and development. You know, there's always has to be close collaboration between people like us and New Holland. I see them out in the audience and others, because what the project needs and the developer needs, we need to know far in advance and to try to develop the necessary equipment needs and changes that help support the industry. I mean, things like how do you manage ash? How do you manage moisture? At some point, are we going to put sensor devices on them that can measure the sugar content? I mean, are we going to eliminate passes out of the field? So there's got to be a close collaboration, and of course the Department of Energy plays a great and important role in that with us and for us, you as developers, us as manufacturers. So that symbiotic relationship is extraordinarily important, and for one, I applaud the work that's been done. It's been not only important, it's been fun, it's been fascinating, and it's developed some really good stuff. And the last point on that sheet is one that you're going to hear more and more about. As we march towards 300 bushel corn, where we have to support the ever-growing population, there's a direct relationship. You heard a little bit about it when Rich was talking. You'll hear more about it in the future, but it's going to be an extraordinarily important point. At that point, you're producing 7.5, 8 tons of residue per acre. There's a direct relationship between the amount of grain produced and the amount of stover produced. At those levels, it's not sustainable to just leave it on the land and do no-till. And then if you're going to till, then you're going to have to do so many passes, or you're going to have, as Ken likes to remind me, you know, 700 horsepower tractors pulling 40,000-pound tillage machines that are going to just destroy the soil. And so residue management is going to be important. The good news is We have benefits of residue management is extra yield. And so what we've noticed is yields increase when you do this management. Just to very quickly, as you can see what it could do to our industry, right now we have about 125 large square balers working in the industry. The total industry is only 1,600 plus units. We sell about 870 of those. If 20 projects were built over the next 3 to 4 years, that number would increase to approximately 4,000 total and 2,400. I can tell you today, we need to know how that's going to develop out. The unique and cohesive energy policy would help. So I've done my job to echo what everybody else has said, because we don't know how it's going to develop. And to do that and to expand that growth and build the manufacturing is going to take a lot of work. This is a baseline multipass system, combine, then you go to the tractor, to a shredder or a windrower to organize, then you go to a baler, and then so on. So many, many steps. That's why there's so much equipment. These are just some pictures: left shredding, right large square baler, 2 different versions of how to collect bales, one tractor pulled, one self-propelled. Field storage, and then truck to what ends up being a remote storage. Each one of those stacks there being about a 1-day supply for the biorefinery. So we will collect during that period of time, that short period of time, some 300 stacks like that. The future, we spend a lot of time baling all types of material. This is a demonstration, harvest demonstration we did on about 60 acres of miscanthus. We were able to put that away, baled, stacked at the field edge in about 8 hours at an operational cost of a little less than $10 per ton. So very, very aggressive and successful demonstration. Big data is going to play a huge role in the future. We know that we can evaluate and help drive the matrices for operators to improve. Last year, we went from 9.2 pounds to 11 pounds density. Doesn't sound like much, but what that means is approximately a $600,000 savings due to lack of handling extra bales on behalf of the biorefinery. So one of the most important factors is bale density. Another thing of the future is taking steps out of the field. We have combined 3 steps into 1 step. This is our single pass system, and then here's a short video. You may have to start the video, I believe. I don't have a cursor to do it. So this is taken just less than 2 weeks ago. This is working in a wheat field in Washington. They are developing their system to collect and bale wheat straw for what's going to be a new pulping mill in the area that's going to use about 250,000 tons of wheat straw a year. And that machine was one that was developed with our good partners at the Department of Energy. So then one of the other most important things about this, it also works equally well in corn stover, maybe even better, is that bale, because that material has never touched the ground, it's being fed directly by the combine. Since it's never touched the ground, that material has an ash content of its intrinsic ash, which is about 3 to 4% in most cases. So there's my contact information, and I certainly appreciate being here. Hopefully we will continue to be here in the future, and look forward to any questions.